All right, hi everybody. What we're going to do is just break down this simple series and parallel combo circuit. And I threw a little capacitor in here so we can see how you can finish up with that as well. The goal for this would be to analyze the current and voltage across each of these resistors and figure out what the voltage and the charge would be on this capacitor sitting right here. So in order to get started, if we've got the current on for a very long time in this circuit, what's going to end up happening is the current here through this capacitor is going to go to zero, which means effectively we can separate this out and take a look at this part of the circuit as if it was just resistors with currents flowing, and this thing would not affect it at all once the current's been running for a very long time. So what we'll do is just take a look at analyzing this part of the circuit first. So generally what we do is we redraw the circuit, and we have to start collapsing these resistors down to find out what the equivalent resistance is. Well, two resistors in series are additive. So we know that we have a 2 ohm and a 4 ohm, which gives us a total of 6 ohms of resistance in this branch. So it's easiest to visualize things if we take this and redraw the circuit as our 3 ohm resistor, and now in parallel with an equivalence of 6 ohms. All right? And I'm going to leave the capacitor off for now since it doesn't affect anything. Okay, now the next thing to do is we can draw this circuit and we can collapse this down as two resistors in parallel. We remember that the resistive law, or the parallel law, would give us 1/3 plus 1/6, and if you figured this out, this is going to give you an equivalence of 2 ohms of resistance once you did all this work. So we can redraw the circuit as if we really only have one 2 ohm resistor in this entire circuit. Now it's a pretty easy Ohm's law calculation to figure out that our total current is going to be our 6 volts divided by our total resistance, which is 2 ohms. So we're going to have a total of 3 amps of current, which is drawn out of the battery and delivered to the rest of the circuit. So what we want to do now is work backwards. Okay, I'll put this in red pen. If this is our 3 amps, okay, we're going to have 3 amps that comes out of our circuit. Some of it's going to go through the 3 ohm resistance, and some of it's going to go through this equivalent 6 ohm resistance. And what we can do is just apply Ohm's law to each branch to figure out how it's going to portion out. Notice that 6 volts, since these are in parallel, are across each resistance. So if we apply Ohm's law to the 3 ohm resistor, the current that's going to go through that 3 ohm resistor is going to be 6 volts over 3 ohms, which would be 2 amps. So we know we're going to have 2 amps coming down this way, which really only leaves 1 amp to go back through this part of the circuit. Or through that equivalent 6, you would get 6 volts over 6 ohms, which gives you 1 amp going to this part of the circuit. Now that lets us see that we do have 6 volts across this one. We have the current through this one. This resistor, we've figured everything out except perhaps the power, which would be 6 volts times 2 amps, or 12 watts, I guess. So across that 3 ohm resistor, we could say I3 V3, which is going to be 2 amps times 6 volts, would be 12 watts. All right. So let's come in here now and figure out what we do with this next part of this branch right here that we have 1 amp running through. Well, it's easiest to look at that if we come up here. What's really happening now is this 1 amp of current is really flowing through this branch right here. Again, no current flowing through the capacitor. So what we have left to analyze in these two resistors is the voltage drop across each one. So we just apply Ohm's law to our 4 ohm resistor. 1 amp times 4 ohms would give us 4 volts. And we know that by the time we get here, we have to be down to 0 volts, right? So that really only gives us 2 volts left across this one, or applying Ohm's law, 2 ohms times 1 amp would give us 2 volts. And then we could do the power through each one. Again, P equals IV. 1 amp times 4 volts would be 4 watts, and 1 amp times 2 volts would give us 2 watts in this case. All right, well now what we have left here is the capacitor. So notice that the capacitance, all right, sees whatever voltage the 2 ohm resistor sees because it's in parallel with it. And the 2 ohm resistor had 2 volts across it. So we know that our voltage across our capacitor is 2 volts. So using our capacitance law and knowing the value of the capacitance, we can figure out the charge on it. So 4 microfarads on with 2 volts is going to give us 8 microcoulombs worth of charge on the capacitor. And that's it.